There was a time when three-engine jets ruled the skies. You'd hear that deep rumble overhead and spot a 727 or DC-10 powering through the clouds. They looked fast, flew far, and filled airports across the world. The Boeing 727, DC-10, and L-1011 became staples of global travel. But today, they're barely a memory. No headlines, no final send-off, just silence. What happened to the Trijet? In this video, we're taking a close look at the rise and fall of the Trijet. Not through nostalgia, but through the facts. How these three-engine aircraft once seemed like the smartest solution in the skies, and why they quietly slipped out of the picture. We'll walk through the bold engineering decisions that made them stand out, the real-world performance that won over airlines, and the setbacks that forced regulators to pay attention. You'll see how each model had its moment, from the sleek Boeing 727 to the powerful DC-10 and the high-tech Lockheed L-1011. And we'll also break down the turning point, where things went wrong. Some jets vanished because they failed. These didn't. They did their job, sometimes brilliantly, until the industry moved on. If you've ever spotted one parked in a forgotten corner of an airport, this story will finally explain why. To understand why three-engine jets exploded in popularity and then faded out, you have to go back to the late 1960s. Air travel was booming. Airports were expanding, jetliners were getting bigger, and more people were flying than ever before. But aircraft design was stuck in a dilemma. Twin jets were fuel efficient, but back then, they weren't trusted for long-distance routes. If one engine failed over the ocean or remote terrain, there was no backup. Regulators simply wouldn't allow it. On the other hand, four-engine aircraft like the Boeing 707 or the 747 could fly anywhere. But they were expensive to run and maintain. So engineers came up with a middle ground, the Trijet. With three engines, airlines got long-range capability without the cost of a fourth engine. It was seen as a smart compromise. Safe enough for longer flights, but cheaper to operate than quads. Boeing made the first major move with the 727 in 1963, designed for shorter U.S. domestic routes with three engines tucked neatly at the rear. Then came two wide-body giants. The McDonnell Douglas DC-10 entered service in 1970 with a larger fuselage and a top-mounted third engine. Just 2 years later, Lockheed introduced the L-1011 TriStar, which pushed even further, offering fly-by-wire controls, advanced autopilot, and a quieter cabin. Suddenly, every major U.S. airline wanted Trijets in their fleet. It looked like the design would define the next generation of air travel. But there was something the engineers hadn't planned for. A series of real-world problems was about to challenge everything the Trijet promised. At first, it looked like Trijets were the perfect answer. The numbers worked, airlines were on board, and regulators finally had an aircraft that didn't require four engines to be considered safe. It all made sense until things started to go wrong. In 1974, a DC-10 operated by Turkish Airlines suffered a catastrophic failure mid-flight after a rear cargo door blew out, leading to explosive decompression. The aircraft crashed just outside Paris, killing all the people on board. Investigators had warned about the faulty door design before. No one expected it would fail so dramatically, or so fatally. While the DC-10 was dealing with scrutiny, the L-1011 faced a very different challenge. Its engine supplier, Rolls-Royce, collapsed financially just before delivery. The delay crippled Lockheed's launch schedule. By the time the TriStar was ready, the DC-10 had already scooped up major airline orders. So one Trijet was fast, but flawed. The other was advanced, but late. What started as a winning formula had suddenly become a risky bet. And the cracks were only beginning to show. The early problems didn't stop airlines from doubling down. If anything, the demand for Trijets kept growing. And rather than back away, manufacturers pushed harder. Bigger cabins, better range, more ambitious features. The Trijet wasn't being phased out, it was just getting started. Liking this breakdown so far? Stick around, because what happens next with the 727, DC-10, and L-1011 will reshape everything you thought you knew about how airliners rise and fall. The Trijets was supposed to be a brilliant middle ground. 3 engines meant more range than a twin jet, but lower costs than a 4-engine giant. On paper, it made perfect sense, but in reality, the design introduced problems that engineers hadn't fully anticipated. That center engine, tucked into the tail, was the biggest challenge. It created balance in flight and met long-range safety requirements, but it complicated nearly everything else. Technicians had to scale the aircraft just to access it. And while the lower 2 engines fed easily from under the wing, the tail-mounted engine needed air delivered through the fuselage. That was not a simple job. Lockheed came up with a bold solution. The L-1011 would use a long, curved intake system known as an S-duct. It started behind the passenger cabin, curled upward through the tail, and fed into the 3rd engine. Aerodynamically, it was brilliant. The airflow was smooth, the engine cooled evenly, and the performance in the air was excellent. Pilots liked it. The flying public didn't even notice it, but the factory did. The S-duct was incredibly difficult to build. It required precision welding, tight curves, and flawless assembly. No part of it could be rushed. Every mistake meant delays. It slowed production, increased costs, and gave Lockheed a reputation for complexity that airlines began to worry about. Over at McDonnell Douglas, the DC-10 went for a simpler approach. A straight intake above the fuselage. Not as sleek, but much easier to manufacture. They hoped this faster production schedule would give them the upper hand. Then Lockheed hit a wall. Just as the L-1011 was nearing completion, its engine supplier, Rolls-Royce, went bankrupt. It happened in 1971. Without those engines, Lockheed couldn't deliver aircraft. The project stalled, assembly lines sat quiet. The future of the TriStar was suddenly uncertain. The stakes were high. Lockheed had already poured massive resources into the Trijet. Without help, the entire program would collapse, so the company went to Washington. After intense debate, Congress approved a rescue package in the form of loan guarantees. It kept Lockheed alive, but not without political backlash. Critics saw it as corporate welfare. Supporters said it was about protecting jobs and preserving American competition in aviation. All this was unfolding while Boeing quietly watched from the sidelines. Their 727 had launched way back in 1963. It had none of these problems. The engines were at the rear, yes, but easily accessible. Airlines were buying it in bulk for domestic routes. By the time Lockheed and McDonnell Douglas were wrestling delays in politics, Boeing already had over 1,000 orders on the books. Still, despite all the trouble, airlines were not giving up on the wide-body Trijet. They saw potential. They believed in the range, the payload, the future. The real question wasn't whether the Trijet would fly, it was which version would survive long enough to lead. No matter how promising a design looks on paper, public trust is built in the skies. And for the Trijet, that trust was shattered twice. The first major blow came on March 3, 1974. Turkish Airlines Flight 981, a McDonnell Douglas DC-10, departed from Paris-Orly Airport en route to London. Just minutes into the flight, the rear cargo door failed mid-air. The cabin floor above it collapsed, severing control cables. The aircraft plummeted into the Ermenonville forest, killing all 346 people on board. It was one of the deadliest crashes in aviation history at the time. The tragedy was beyond being a mechanical failure. It was more about the warning signs ignored. Engineers had previously flagged concerns about the DC-10's cargo door latch mechanism. In earlier tests, the door had blown open on the ground, but the issue was patched with a service bulletin rather than a mandatory fix. That choice proved catastrophic. The aftermath was brutal. European regulators grounded the DC-10. News headlines screamed of design flaws. Families demanded answers. McDonnell Douglas went into damage control mode, redesigning the locking system and reinforcing the cargo hold. But public confidence had taken a serious hit. Then came the second blow, even closer to home. On May 25, 1979, American Airlines Flight 191 was scheduled to fly from Chicago O'Hare to Los Angeles. During takeoff, the aircraft's left engine tore completely away from the wing, severing hydraulic lines and damaging lift systems. The DC-10 rolled violently, stalled, and crashed just beyond the runway. All 271 people on board were killed, along with 2 more on the ground. This time, the footage was inescapable. News stations played it on loop: black smoke, twisted wreckage, rows of body bags. Investigations revealed that American Airlines had used an unauthorized maintenance shortcut when removing the engine for servicing. But again, critics pointed fingers at the aircraft design itself. If the system failed so catastrophically when one engine detached, how safe was it really? Within days, the Federal Aviation Administration grounded all DC-10s operating in the United States. Airline schedules crumbled. Passengers canceled tickets. For many, Trijets no longer looked like a safer middle ground. They looked risky. Even though both accidents had specific causes, cargo door mechanics in one, maintenance errors in the other, the headlines made no such distinctions. To the flying public, Trijets were the common factor. That perception stuck. McDonnell Douglas rushed out safety upgrades. The FAA tightened certification rules. Pilots were retrained. Maintenance procedures were rewritten from the ground up. The fixes came fast. But the damage was already done. Airlines struggled to win back passenger confidence, and the shadow of those 2 crashes lingered over every Trijet that followed. It was no longer just about performance in the air. It was about reputation on the ground. While the public wrestled with safety fears, another threat to the Trijet was quietly gathering momentum. It wasn't dramatic. It didn't make headlines. But it would become the most lethal force in the Trijet's downfall. Why? The answer is simple: efficiency. Throughout the 1980s, the aviation world started shifting towards something simpler: twin jets, 2 engines instead of 3. They were easier to build, easier to maintain, and far cheaper to operate. But until then, they had one major weakness. Regulators didn't trust them to fly far from land. If one engine failed, there was no backup. It meant that twin jets were restricted to shorter, safer routes over land. That changed in 1985. The Federal Aviation Administration introduced ETOPS, short for Extended Range Twin Engine Operational Performance Standards. For the first time, certain twin-engine aircraft could be certified to fly over oceans and remote regions. If they could prove their engines were reliable enough, they could operate up to 120 minutes from the nearest airport. That rule completely shifted what was possible. Planes like the Boeing 757, 767, and Airbus A310 suddenly had global potential. Airlines didn't need 4 engines to fly transatlantic anymore, and they didn't need 3 either. The third engine, once seen as insurance, started to look unnecessary. And it wasn't just about range. Fuel prices were climbing. Twin jets burned significantly less fuel than their 3-engine counterparts. Less weight, less drag, fewer moving parts. In an industry where margins are razor thin, every saved gallon mattered. The difference could mean millions of dollars annually for a major carrier. Maintenance was another game changer. Fewer engines meant fewer inspections, lower downtime, smaller spare parts inventory. Mechanics could work faster. Ground crews needed less specialized training. Across the board, the numbers favored twin jets. By the early 1990s, more and more carriers were shifting their orders. American Airlines began favoring Boeing 767s. Lufthansa invested heavily in the Airbus A310. British Airways phased out the Lockheed TriStar in favor of twin-engine options. Even former Trijet strongholds in Asia and the Middle East began to pivot. And the Trijets couldn't keep up. The DC-10 required more maintenance hours per flight than newer twin jets. The L-1011, with its complex S-ductant systems, was expensive to support. Airlines began to ask a simple question: why pay for a third engine we don't need? The answer was clear: they wouldn't. By the mid-90s, ETOPS extensions had grown to 180 minutes. That covered nearly every major ocean crossing on the planet. The old regulatory reasons for 3 engines were gone. What remained was cost. And on that front, the Trijet simply couldn't compete. The third engine wasn't a safety asset anymore. It was dead weight. And as airline fleets modernized, the Trijet was left behind, quietly retired. No fanfare, just numbers on a balance sheet that no longer made sense. As the twin jet revolution took hold, there was one final push to keep the Trijet dream alive: In 1990, McDonnell Douglas introduced the MD-11, a stretched and modernized version of the DC-10. It featured updated avionics, a longer fuselage, winglets for better fuel economy, and an advanced cockpit. On paper, it looked like the right move, a next-generation Trijets that could stay relevant in a market now shifting toward twins. But the reality didn't match the promise. Fuel burn was higher than projected. Its range disappointed some carriers. And while pilots appreciated the upgrades, many reported challenges during landings. The MD-11 wasn't unsafe, but it wasn't exceptional either. By this time, aircraft like the Boeing 777 and Airbus A330 were already proving their worth. Both were twin jets, both were more efficient, and both avoided the complexity of a third engine. Major airlines noticed. Passenger orders dried up. Operators like Delta, Swissair, and Finnair gave the MD-11 a trial, but few stayed with it for long. It simply couldn't compete. The economics had shifted. The third engine that once symbolized safety and range had become dead weight. But while passengers moved on, cargo carriers stepped in. The MD-11 had real appeal in the freight world. Its payload was excellent. It could fly long distances, handle shorter runways, and still operate reliably with that extra engine. FedEx quickly became the biggest fan, acquiring more than 60 MD-11s over time. UPS joined in too. Lufthansa Cargo added the jet to its fleet, using it for transatlantic and Asian freight routes. For them, the Trijets still had value. Even so, its time in commercial passenger service was ending. The final scheduled flight came in 2014. KLM, the last major airline flying the MD-11 with passengers, operated a farewell route from Montreal to Amsterdam. There was no national coverage, no ceremonial send-off, just a full flight of aviation enthusiasts, quietly honoring a machine that had served for decades. And with that flight, the Trijet era closed. These aircraft once dominated front pages in the 1960s, yet by the 2010s, they had slipped into quiet obscurity. There was no dramatic finale, no sudden ban. Their exit came through slow, steady change, aging fleets, shifting economics, and the march of technology. The Boeing 727 launched the idea with its distinctive rear-mounted trio. The MD-11 tried to carry the vision further with greater range and ambition. Over 5 decades, the Trijet bridged continents, carried millions, and helped define a golden age of air travel. But in the end, the very feature that once set it apart had become unnecessary. But by the end, its signature feature, the third engine, was no longer an advantage. It was a relic of a different time. The Trijets were monumental. They helped shape what air travel meant for decades. They flew business travelers across continents, reunited families for the holidays, and took curious minds to new corners of the world. From the roar of the engines to the curve of that third one tucked in the tail, they had a look and sound all their own. You can still find some of them, tucked away in desert graveyards or standing proudly in museums. A few even take to the skies now and then, mostly hauling freight. But even the ones that no longer fly left something behind. They helped airlines stretch farther, fly smarter, and think bigger. For pilots, flying a Trijet was something special. For engineers, building one was a chance to solve problems few had tackled before. And for passengers, stepping aboard meant being part of a moment, be it a vacation, a farewell, or a first time seeing the clouds from above. The world moved on, as it always does. Quieter engines, longer ranges, leaner fleets. But the Trijets didn't just fade. They left a trail, in memory, in legacy, and in every quiet corner of aviation where someone still stops to look up. Some stories in aviation don't end with drama, they just get overtaken. That's why we dig into aircraft like this, not because they were total failures, but because they shaped the routes, fleets, and decisions that led to the world we fly through today. If you're into the machines that flew under the radar, or the designs that were bold enough to try something different, this is the place for you. Go ahead and tap subscribe. We're building an archive of the overlooked, one video at a time, and we'd love your input. What aircraft or design do you think deserves a closer look, something history didn't spotlight, but maybe should have? Could be a short-lived model, a prototype that never made it, or a plane with features nobody talks about anymore. Tell us in the comments. You just might help shape our next story. Thanks for watching, and if you learned something new today, that's exactly why we do this.